Good morning and welcome to the weekly Wednesday webinar. My name is Christiana Holmes, and today we're going to be going through Chapter 6 of the new Plan Development Manual, Cross Sections and Sheets. In this webinar, we're going to go over creating the existing and proposed cross sections, labeling the cross sections, placing ancillary features, placing the geotechnical information, calculating the earthwork, laying out the cross sections on sheets, and creating drainage structure cross sections. So let's just dive right into it. I'm already in a cross section file that was created through Vern's manual. This is the shape file. So I'm going to start here, and I am in the pattern model. And the first thing you want to do is reference in your 3D surfaces that you want to show up in your cross section. So we need to reference in the existing 3D surfaces, which is the GKL and RDO1 file, as well as the proposed design file. We also need to reference in our terrain model. And because the cross-section tools will use both some of the old tools and some of the new civil tools, I'm going to go ahead and set up my project manager in Geopack. So on the FDOT SS3 workflows, we have a workflow dedicated just for creating cross sections. And the first icon is the create cross sections, and this is a new tool with the civil tools. So if you just click on that tool, you'll get a little prompt at your cursor that says locate alignment. So you'll locate the alignment that you want to create cross sections for it, and I'm going to do State Road 61, this alignment here. If you hover over it, you'll see that it says it's State Road 61 and has an active profile. And then you have to give this dialog a little while to come up. It takes some time. And on this dialog, there are several different tabs over here to the left. The main tab that you're going to be changing the information on is this first tab, the General tab. And for all of the other tabs, most of the settings have already been set up for the different FDOT scales and sheets using these preferences. So to load those preferences, first click on the Preferences button. And then you'll see that we have preferences set up for cross-section sheets at a 10 scale with earthwork, 20 scale with earthwork, 40 scale, and 40 scale with earthwork. I'm going to choose this 20 scale with earthwork and click Load. And if you notice, some of the settings changed in here, and that will set up all of your cross-section cells and information so that you can create 20 scale sheets with earthwork. Click Close when you're done. Now we want to set the start and stop stations. So I'm going to start at station 700. And I'm going to stop at 720. And I'm going to leave the offsets alone and the interval and exaggeration as is. And then I'm going to change the view because I don't want it to display in this view that I'm in now. I want it to display it in a different view to 3. And one of the most important things you want to have set is the layout. There's 2 different settings here. One is stacked and one is sheet. Stacked will create your cross-section cells along with all of the cross-section information. Sheet will place all of the cross-section information on a sheet, but there will not be that purple cross-section cell available. And the problem with creating the sheet layout is that some of the tools like placing Ancillary Features and Borehole Navigator still need to use those cross-section cell. So I'm going to leave this set at stacked, and then you can give it a model name, or you can just leave it at that model name if you want. So when you're satisfied with all of these settings, then you can just click apply. And then you'll see down here at the bottom there's this progress bar, and it will go through and let you know when it's 100% complete. So now my cross sections are created in the view 3, and it created another model called State Road 61. And I can close out of this. And if you want to navigate through your cross sections, there's this Navigate Cross Sections tool that's on the cross sections workflow. This is just like the tool that was in SS2. And you can see that your existing ground line and your proposed cross sections have been plotted, along with the cross section cell. One issue with creating the existing features and existing, let me go to a cross section that has existing features on it. Existing line work with the surface tools, as Vern has showed you in one of his webinars, is that everything looks fine here in the cross-section file, but when you go to print, you'll see that there's like an actual shape, and it's on top of this existing ground line. And so when you go to print, this looks like a solid line. And we have created a tool to get rid of these extra lines out here, and it's the second tool under this cross sections workflow called Delete Duplicate Lines. So if you just click on that icon, it'll go through and get rid of those extra lines that are in the cross sections. And so now you'll see that those lines have been removed from being on top of the existing ground line, and when you go to print, you won't have like a solid line up here on the top. So now that we have our cross sections created, we can label them. And to label the cross sections, there's this Label Cross Sections icon under the cross sections workflow. There's two different ways you can label cross sections. I'm going to show you the one that's in the Plans Development Manual, and then I'll show you a different option as well. And sometimes, I don't know why, but you get this a blank cross section model, and it doesn't want to select the stations. So let me try to recreate this cross-section model. Just bear with me for a minute. A couple questions out here. Do you still have to plot the existing ground twice in order for the elevation value to show up? I'm not sure what elevation value you're speaking of, but you shouldn't have to plot the existing ground line except for once, and this will plot it everything all at one time. Okay, now it's showing up. So you'll have to select this cross-section model, and this one is set to State Road 61 cross-section, the one I just created. And then you'll want to set the station range. If you toggle that on, you can select the start and stop station. Or if you leave it toggled off, it'll just do the entire station range. So just like the preferences that we have set for the creating the cross sections, we also have preferences for labeling the cross sections, and these preferences will set up all of these folders and the labels so that you don't have to make any changes on your own. So let's say you wanted to label the PGL elevations. You will just click on the preferences and select the preference PGL elevation and click load. And then if you go to the features tab, you'll notice that this box is toggled on. That means that this is what's going to be labeled. If you go to the other tabs, you'll see that these are toggled off. And that's because this PGL elevation is set under this features folder. And then after you set the preference, you want to select the point on your cross section that you want to label. So you can do this one of two ways. You can use this picker, as Vern calls it, and go out and select a point, and it will highlight it in the list. Or you can just select the point yourself. So we're going to do the right PGL in, and then click apply, and then you'll see that your text is placed in your cross section, and this is for each station. In your station range, and if you wanted to do it for select stations, you would change the station range here. You can also do more than one point at a time. So say you want to do your left and right PGL at the same time, you could just hold down the control key and select your left PGL. And then both are labeled at the same time. Let's say if you wanted to label a slope of your roadway, so then you would need to go back to your preferences and look through the different types of labels and select like the proposed grade slope and click load. And then you'll notice that the features include features toggle box is turned off, and then if you go to segments, you'll see that it's a segment type of label, and that the slope is toggled on and the format is set to %. And you can change these settings if you want. They just won't be saved in the preference. So say I wanted to change this to like 2 decimal places instead of 0, I could change that, and then that will label my slope with 2 decimal places. For the segment, you're going to need to select 2 points. So you would go out here, choose the first point of your slope and then the second point, and it'll highlight both in this crossing features box. And then you click apply and your slope has been labeled. I have a couple questions up here. It says, what were the files that you loaded up at the beginning of the run? The reference files were the proposed design, which will be your design file, your existing features, which is that GKL. I'll show you in the reference file. GKL NRD 01. And then your terrain model, and the proposed design file is gonna show your proposed line cross section Your GKL and RD is going to show the existing cross-section information, and your terrain model will show the existing ground line. The second option that's not in the plans development manual for labeling is using the old cross-section labeler that was developed in SS2. But before you are able to use that labeler, you must place the feature names inside your cross-section using this labeler tool. And we actually have set up a preference to label the feature names called feature names only. So if you select that preference and hit load, you'll go back to your features and see that this is toggled on and that it's going to label the feature name. And it's getting this name from your template that was used to create your corridor in your design file. So then once you have the preference loaded, you'll go to annotate, and then you want to annotate all of the features that are in your State Road 61 template. So you'll select all of the crossing features that have this State Road 61 in front of it. And you can use the Control and Shift keys to select all of these. And then once you have all of the State Road 61 features selected, you just click Apply. And if you zoom in real close, you'll see these small little feature names out here. I think I missed some. And then once you have all of the feature names, you can go in to the roadway menu and go to this cross-section labeler VBA. And that will load all of the old cross-section labeler that was available in SS2. And it's a little bit more user-friendly than this one can be at times. So that's why we made both options available. And basically, to use this, you would just select your job number, your chain, and your begin and end stations, and then you have several different update options you can choose to remove all of the labels, delete existing ones, and redraw. And then you can do different types of label depending on the tab that you select. And basically, you just ID the feature name as the begin and end point and give it a symbology. And then load it up here, and then click Draw Labels. And then you can set this to be bigger or smaller if you need to be, but it'll place the label out there. For the new, there's a question out here that says, what are the label update options for the new dialog box? And that's one of the problems, is that there's not any update options for this dialog. So once you place a label, if you can undo, like you can undo in the file, but you can't just delete the labels that are currently out there without doing it manually. Okay, the next step is to place the ancillary features. So I'm going to close out of this dialog. And on the cross sections workflow, there's this Draw Ancillary Features icon. And this is the old tool that was used, that's been used for many years. It still works the same. And since we have this cross-section cell and we use the stacked option, we can use the Draw Ancillary Features dialog just as we have in the past. So you'll use this to draw features such as your existing utilities and right-of-way lines on your cross-sections. But before we start drawing the ancillary features, we're going to need to go back to our pattern model and reference in any files that we're going to want to draw the ancillary features for. So like if we want to do existing utilities, we need to reference in the UTEX-RDO1 file. And then if you want to do right away, you need to reference that in as well. So the first thing you want to do is make sure you have the correct job number selected. And then you want to choose the chain. And you need to be in the cross-section view. So since I have just one chain, it automatically popped up there. And then you want to choose the view to be cross-section. And then for this cross-section, for these features, we want the 20 labels to be 20 scale. And then under intersecting elements, you want to set this to, there's several different options, but we don't have a chain of our existing utilities, so we're going to just use the level symbology. And this is the level that it will go out and search for in your, like, say, your utility file or your right-of-way file. This is the level that it's going to go out from the alignment and search for. So we want to make sure that we have all of the I'm going to do sanitary first. So I want to make sure I have all of my existing sanitary lines that could be in my utility file checked on. You can also do a match and go back into the pattern file and do it that way if you want, but it's up to you. And you want to set the DGN file that you're searching for to the utility file. And then we want to set the elevation, so what elevation is going to be placed in our cross sections. So we want to extract the elevation from the existing ground line. So we're going to set this again to level symbology. You can use the 10 file for the elevation if you would like. It's just user preference or what's best for your project. And then you want to click on this box and select the existing ground line. And you can do, like if I reset this and do match, you can just match this line out here. And if you click this display button, it'll show you the line that you're using. And then for your display settings for the utilities, we typically use an oval, so we'll set this to a symbol, and the symbol will be a circle. And then you want to use the cross-section level symbology for sanitary sewer. And then the justification can be set to center top or any of the options here. This is just user preference. This is going to base where this symbol is justified from the ground line. And then I'm going to set this to -1.5 for the vertical offset, and I'm just going to use a height and width of 6 inches. And once I have all of this set up, I just hit this add element to set, and then I'll add it to this list. Along with the symbol, we also need to create a label for the utility. So we'll change this display setting to text and label it SAN for sanitary sewer or sanitary. And then you want to make sure you set the text symbology to the correct level and the correct size. And then you want to make this a little bit lower so it's not right on top of that, right on top of the symbol. So I'm going to go down a little bit. And all of this can still remain the same because it's still looking for that sanitary line in the utility file. So once you have that complete, you can add that and it'll create another line for the text. And you can do multiple different utilities or ancillary features in this box, or you can just create one, draw it, create the next one, and draw it. It's just up to you. So I'm going to create this one and click draw, and then you get an update option, and it asks you if you want to draw on top of it draw existing elements and redraw, delete the elements and redraw, or draw on top of existing elements, and that's what we want to do. So click apply. So then it runs through each of your cross sections, and you'll see that there's a sanitary sewer to the left of the alignment in this location. You can save these files so that if you need to recreate your ancillary features, or you have to recreate your cross sections and you need to recreate ancillary features again, you can just click File, Save As, and it's an AFD file. Now you can do this for your right-of-way lines as well. The right-of-way lines that are out here were placed using the 3D elements in the GKLNRD1 file. I wouldn't recommend using that at this time, just because these can't be scaled up and down. They're like stuck at a scale unless you manually do it. And that process is shown in Vern's manual, and he's gone over that in webinars. But I would just use this draw ancillary features to do any type of right-of-way utilities, anything like that, temporary easements or anything. So the next tool that we're going to use is the Borehole Navigator, and this is used to place any geotechnical or borehole information in your cross sections. And this tool is used just like it was in SS2. This is an old tool, so nothing has changed as far as this tool is concerned. So you'll get the first you want to create a geotechnical database. So on the Borehole Navigator toolbox, you'll just go to File, New, and I already have one out here, but I'll create a new one. And you just name it whatever you want, and click Save. And then you'll give it the job information or project information, such as the job number and the TIN file. And I'm going to toggle on this override user provided elevation using the TIN file, and click OK. And then you have this geotechnical database file set up. Next, you'll want to import the borehole location data, and if you go to File, Import, CSV, Borehole, want to import this BRH file, and this file should be provided from whoever's doing the geotechnical work for your project. So you select that file and click Open. And then all of your borehole names and location, as well as the water elevation information, will be loaded. Next, you want to import the material information for each borehole. So you'll go to File, Import, CSV, Material, and then you'll want to import this MTL file. And this file should also be provided from the geotechnical engineer. And this contains all of the borehole names and material information. And then if you click this little arrow at the bottom of this box, you can go through each borehole and see what the material and depth of cover is for each one, as well as this elevation, the elevation and the water table elevation. Then save this information to the database file that we created. So go to File, Save. And to plot the boreholes in your cross sections, you want to click on this Visualize Boreholes in Cross Section View button. And that'll bring up the dialog, and then you'll need to select the correct chain. And then that populates all of the boreholes that are on this chain. And you can set a station range if you want to just do a certain range of the borehole information. But I'm just going to leave this at 700 and 720. For the projection data, there's a couple of options, like you can draw only on exact cross sections, but most of the time your borehole information won't be on exact stations. So you want to select the project onto nearest cross section, and then you want to set the max projection distance to 20 to something in between your cross section. In this one I have 50 feet interval cross section, so I'm going to set it to 25, so that if it lands like dead in the middle of in between two cross sections, it'll place it at the nearest one. So if you had like 100-foot intervals, you might want to set that to 50, just so that it will place it at the nearest cross section. Otherwise you'll get an error saying that there's not a cross section near to that distance. You want to place the projected borehole at ground elevation, and you want to set that level to the existing ground line. And you can display it just as you did in Ancillary Features dialog. So once you have all of this information set, you just select all of the boreholes in this list and click Apply. And then if you go through your cross sections, you'll see the boreholes that have been placed at the correct cross section stations. And see, this one was actually at station 704 plus 32, but because the closest one was cross section was 704 plus 50, that's the cross section it plotted at. And then you may have to adjust your text and your labels to view properly on your cross sections, but that's pretty much all you have to do for Borehole Navigator. So close this dialog. And the next dialog or tool that we're going to use is to calculate your earthwork, and this is a new tool. If you go to the cross sections workflow, there's an icon called Calculate Earthwork. You just click on that, and this End Area Volumes dialog will pop up. And under the General tab, you'll want to set the method to standard and the units to cubic yards, and then you can toggle on the station range and give it a start station of 700 and end station of 720. And then you can toggle on this Create XML report, and that will do just as it says. It'll create an XML report of your earthwork quantities. Next, the next tab you'll want to go take a look at is your Classifications tab, and then under this tab you have several different columns, and the main one you want to focus on is your objects, and you want to make sure they're classified. The existing objects are classified as unsuitable material, so you'll need to go through each object and make sure anything that has EX at the end is set to unsuitable. And then once you have that done, you can go to the Annotation tab, and this is where you would set up the colors or the of your shapes for your cut and fill, and then also the text that will go to the right of your cross sections for your cross section sheets. We also have a preference set up for this as well. It's called Earthwork. If you go to the preferences and just select the earthwork and click load, it'll load all of that information and toggle on the cut, shape, and fill, as well as the text that will be placed for those volumes and areas. You can change or add to this if you like, but this is already set up for FDOT sheets. And once you're finished setting all of this up and you are ready to calculate your earthwork, you just click apply. And then you'll see that the end area volume report, which is the XML, pops up, and this is all of the area and volumes for each station of your cross sections. And you can actually save this file out to your project, and you can save it as XML, a document file, or I think you can save it as a CSV file as well. And then click close. And then you'll notice that the shapes have been placed as well as the values for your earthwork quantities to the right, and this will show up when you go to place your sheets. The next thing we want to do is create our cross-section sheets. So the last tool under this cross-sections workflow is the layout cross-section sheets icon. So if you just click on that, and then first you want to go to the sheet model, which is this SHG model. And then on the cross-section sheet composition dialog, you have this active cross-section sheet options, and then underneath here are these different options for different scales and for different scales with earthwork. And this will set up most of these settings over here for the different types of scales or earthwork. So I have a 20 scale cross-section with earthwork, so that's what I'm going to choose. And then all of these settings throughout here can be changed and saved off into a different cross-section sheet library. This is where these are saved, is this .xssl file. And if you wanted to create one for your project or your company, you could create your own cross-section sheet library and give it different labels and stationing and just whatever you want to set it to. These are set to match the preferences that all these other tools use. So the first thing you want to do under this cross-section DGN option is select the your cross-section DGN, which is the file that we're in, which is the RDXSRDO1 file. And then you'll select, if you had more than one baseline, you would select the baseline, but since we only have one, it populates all the information for you. And then you go to sheet DGN file, and we want to place the sheets in this file as well, so we want to select the cross-section file again. And then all of this information is already set up using this cross-section sheet library. So we don't have to manipulate this unless it's needed for your project. So once you have that selected, you just click Layout Sheets. And the sheets are laid out in this sheet file, just as they were in SS2. And then, of course, you can see that the earthwork quantities are all here. You can also go in and turn off all of the levels that you don't want to see. Such as the cross-section cell and the earthwork shapes and anything else that you may want to turn off. And then you can also label your sheets with Sheet Navigator. just like you would in SS3 or SS2. And then do a fit, and then save your settings, and your cross-section sheets are created. Then we had a lot of questions about creating drainage structure cross-sections in SS3, so I'm going to go over how you would create the cross-sections for your drainage structures. So I already have a drainage structure file out here. This is drxsrdo1, and I'm going to open it. I'm going to go to the pattern model. And in the pattern model, I have referenced, just like I did for the roadway cross sections, I referenced in the design file the existing elements, existing features, GKL and RD file, the terrain model, and then I also have referenced in the proposed drainage. And then basically you're going to create your under the drainage plans workflow, there's this draw drainage pattern lines, and this tool is available in SS2 as well. So you're going to create your pattern lines just like you did in SS2 for each drainage structure. So you want to set the job number, and then select the chain, and then set the drainage element search distance from center line. So this is how far out this is going to search for drainage elements. So I'm going to set it to 200 feet. And then you want to select your drainage structure design file where you're going to place your pattern lines, which is the file that we're in. And we want to do it in the pattern file, pattern line model. And then this is how far out your pattern lines will go. So let's say 150 feet to the left and 150 feet to the right. And we want our pattern lines to be on pattern line level. Click OK. And then you'll just click Draw Pattern Lines. And then you see that the pattern lines are drawn out here for the different drainage structures in this file. And then once you have your pattern lines drawn, you can go back to your cross-section workflow and click on this Create Cross-Sections again. And then select the alignment, which is the State Road 61. Close out of this. And then load your preferences for the scale and the size that you want your cross sections to be. So I'm going to just do the 20 scale cross sections without earthwork. And then instead of setting a start and stop station, you're going to want to go to this custom tab, and you're going to make a selection set of all of the pattern lines that you just created. So I'm going to go out here and just add all of these to a selection set. And then once you make a selection set, if you go to this type and change it to line string, you'll see that this graphics button comes available. And so once you have this, you just click on the graphics button, and all of those stations will populate in this list. And then you can save this setting of this to a file, so that if you wanted to create cross sections again, all you would have to do is import it. So you would just save it into this .xsc file. So then you go back to the General tab and make sure that you have the correct view. All of these settings should be the same. Ignore the start and stop stations. Leave the layout as stacked, and you may want to give it a different name. And then you just click apply. And then all of your cross sections are drawn for each station that was in that custom list. And then to add the drainage structures, you would do the same thing that you've done previously, is that you would go to the drainage plans and then create a stub out report. And then you would use the geopack tool, the cross sections tool, to draw your cross sections. And that will go and place all of the drainage structures out here on these cross sections. You can place cross section, or you can use SU to create a 3D model of your drainage file and to have the drainage structure show up on your cross sections. But if you use SU, you won't have the labeling aspect like you do with the geopack cross section layout. So it will draw the drainage structures in your cross section using SU, but you will not be able to label it like you would with geopack. So that's why we haven't really pushed using SU as of right now. If you wanted to use SU, you would just go back and to your pattern lines, and you would have to go into your proposed drainage file and then load that project, import that GDF file from the subsurface utility tools, import that GDF file, and then that will import into it will create a 3D model. And then once you create a 3D model, when you cut cross sections, it'll show up in your cross sections. But it just won't have any labeling attached to it. And that's pretty much all I have for today. If you want to check out the training and go through this project on your own, it's here in under our website under FDOT CAD training. The drainage information is not available in the Plans Development Manual. It is available in the Drainage Manual, and that should be posted sometime soon. That's been revised, and all of the new drainage information will be in there, and how to cut cross sections will be in there as well. So if you have any questions, you can always give me a call or send me an email. Like I said, the training manual and the data set is at this link. And also you can send an email or questions to our support email at any time. And I'll leave the webinar open for any questions that may come up. But thank you for attending, and have a great day.